right, today is the day where we introduce the mole. What is the mole? This is something that chemistry students typically have heard about from previous years, although you may not know what it is. Today's the day that you learn what it is. And even though there's a picture of a real mole on the slide, the chemistry mole is completely different than the furry animal that lives under the ground and destroys your yard. So far, with this unit, we've been dealing with numbers that are on the atomic scale. Things like the atomic number, which is the number of protons. This is a good review for your quiz tomorrow, by the way. We've also talked about mass number, which is the number of protons plus the number of neutrons. And we've talked about atomic mass, which is the number of AMUs in one average atom of that element. All three of these things are going to be on your quiz tomorrow. Protons, neutrons, electrons stuff, and one average mass. All of these numbers are on a really small scale. In other words, they measure or count very small things. When we're trying to measure out chemicals for a lab, though, is it logical to try to measure things this way? Can we count 6 protons? Put 6 protons in a beaker? No. Can we count AMUs? Use the balance and weigh out 10 AMUs of carbon. No, we can't do that either. So we need a bridge to get from these numbers that are really, really small to numbers that we can actually use in a lab setting. We need something to get us from that really small scale to a larger scale that's a lot more practical. We need a bigger scale. We need a bigger size number to be able to do everyday measurements and calculations. Learning about this idea called the mole is going to be that bridge. The mole is going to be that larger scale that allows us to weigh out things in the lab, that allows us to do those experiments on an everyday kind of scale. And the one thing that you have to keep in the back of your mind today about what is this mole idea is that it's a unit. It's a label. Just like centimeters is a label, just like grams is a label, the mole is a label. It's a unit. And specifically, it's a unit that counts things. It counts how many. We have lots of other units that count things. For example, a dozen eggs tells us how many eggs. How many eggs are in a dozen? 12. Can you count other things with the word dozen? Can you have a dozen donuts? I wish we had a dozen donuts today. That'd be nice. How about a dozen cups of coffee?
That'd be good.
That'd be good. I could go for that. A dozen is simply a number. It counts things. It counts 12 of something. You can have 12 eggs, 12 shirts, 12 cups of coffee, 12 donuts, 12 whatever.
Why do they call it a dozen? You just say 12.
Well, it's just a word that counts things. That's all that it does. It's just like saying a pair of
It
shoes.
just counts things.
How many things are in a pair? 2. How many things are in a trio? 3. We could even go with, what's a quintet? 5. We have lots of words that count things. The mole is just another one of those words. It counts things. You can have a mole of particles. You can have a mole of eggs. You can have a mole of donuts. That'd be a lot of donuts, by the way. But it just counts things. That's all that it does. 1 dozen eggs is 12 eggs. A dozen tells you it's 12. 1 mole is 6.02 times 10 to the 23rd particles, atoms, eggs, things. All that it does is counts things. The mole is just another one of those words that tells you how many. Just like a dozen tells you 12, and a pair tells you 2. The mole tells you you have 6.02 times 10 to the 23rd things. It's a really large number. Why do we need such a large number? because we're going to be counting things that are very, very small. And if you're counting things that are very, very small, you can have a lot of them. So the mole is 6.02 times 10 to the 23rd particles. Particles can be anything. You can count anything with a mole. This particular number, it's kind of an odd number. 6.02 times 10 to the 23rd. Who thought of that? This is called Avogadro's number, named after this guy, Amadeo Avogadro. How'd you like that to be your name? Amadeo Avogadro.
That's
It does sound like avocado.
Oh.
The mole is named after this guy and his contributions to chemistry.
Wow, looks like a mole.
Unfortunately, he does kind of look like a mole. Unfortunately for him, this is kind of how things go in science. Nobody cared about his ideas until after he died. So he didn't know that he came up with one of the most important ideas in the study of chemistry. But this is called Avogadro's number, 6.02 times 10 to the 23rd. You are going to have to remember that number eventually when we get to testing on this. P.S. This is not on tomorrow's quiz, but when we get to the test, you'll have to know that number. And the way that I remember it is kind of like a phone number. If you need the mole, call Avogadro, 602-1023. 602-1023, just like a phone number. If you need the mole, call Avogadro. Okay, so where did this number come from? This is kind of a strange number. It just kind of seems to be a random number that we just pulled out of the air. Where did this come from? It turns out that scientists have found that there is exactly 1 mole of atoms in the atomic mass of an element when that mass is expressed in grams. And this is kind of a mouthful. So there's probably this little question in the back of your mind going, what? Huh? We'll explain this in a little bit more detail in just a second. There is 1 mole of atoms, there's 6.02 times 10 to the 23rd atoms, in the atomic mass of an element when that mass is expressed in grams. The easiest way to understand that definition is to look at an example. So if we take one isotope by itself of carbon, let's take carbon-12. What is the atomic mass of carbon-12? This is kind of a trick question because if there's only one isotope here, the atomic mass is the mass number. So what's the mass number of carbon-12? 12. So the atomic mass of C12 is 12. 12 AMUs, to be more precise. So far, we've been weighing all of our atomic masses in AMUs. Remember, 1 proton is 1 AMU, 1 neutron is 1 AMU. The next part of our definition said, express that mass in grams. So we switch the label. Instead of 12 AMUs, we say 12 grams. Switch the label. And if you put that piece of information with our definition, it turns out that if you have exactly 12 grams of carbon-12, in that amount of grams, there is 1 mole of atoms. In that amount of grams, there's 6.02 times 10 to the 23rd atoms. So if you could weigh out 12 grams of carbon-12, you would be holding a mole of atoms. I don't have any pure carbon-12 for you to do that with, but this also works for our average atomic masses from the periodic table. So I have some elements here to pass around, so you can actually hold a mole of atoms in your hand. You can see how much it weighs and what size it is. First one is copper. Can you find copper on the periodic table? What is its atomic mass over there? The average atomic mass? 63.55. I have a bar of copper that weighs 63.55 grams. In this bar of copper, there are 6.02 times 10 to the 23rd atoms. Next one. This one's aluminum. What is aluminum's mass? 26.98. Is it the same mass as copper?
No.
No. Its atoms are not the same size as copper atoms. So there's 6.02 times 10 to the 23rd copper atoms in this bar. There's 6.02 10 to the 23rd aluminum atoms in this bar. Are they the same size? No, because their atoms aren't the same size. In fact, they don't weigh the same either. And we'll pass those around so you can see that they don't weigh the same. I also have iron. What is iron's mass? Fe? 55.85. And I have zinc. What is zinc's mass? 65.39. Again, are they the same size?
Yes.
No, because their atoms aren't the same size. But there's the same number of atoms in each bar. If you think about the mole being like a dozen, if you had a dozen eggs and a dozen marbles, stay with me here, folks, a dozen eggs and a dozen marbles, would they take up the same amount of space? No. Would they weigh the same? No. Do they have the same number of things?
No. Yes.
Yes. That's that idea that I'm passing around in your hand. There's the same number of atoms in each of those bars, even though the bars are not the same size and they don't weigh the same amount. So, in exactly 12.01 grams of natural carbon, there are 6.02 times 10 to the 23rd atoms. And we know that 6.02 times 10 to the 23rd atoms is equal to 1 mole. So 1 mole of carbon is equal to 12.01 grams. See how all of these things are equivalent to each other? All of these things are equal. These sound suspiciously like conversion factors, those things that you do factor label with. Factor label problems are about to become very important. Okay, let's do some examples. Before we get to the examples, I have one last hint for you. I added this slide in last year because I felt like it needed to be there. Remember, I said this at the beginning. The mole is our bridge from things that are really small, like atoms and particles, to things that we can actually measure, like grams. The mole is what gets us in between the things that are really small that we can't see and the things that we can weigh and we can see. So let's do some practice problems. These are going to be very easy. We're starting with the easy ones first. How many molecules are in 2 moles of water? These are factor label. With factor label, you always start with what you're given. What are we given? 2 moles of water. Start with what you're given. Just in case you're not familiar with this kind of format up here, I do this with my fractions on the computer because it's easier. So every time you see a vertical line, that's a break between the next fraction. Make sense? We're going to come back to it. We're doing them in different order. We need to cancel the moles because that's not what we want our answer in. So where do they have to go next? Diagonal on the bottom. How many things are in a mole? 6.02 times 10 to the 23rd. And again, it does not matter what those things are. So there are 6.02 times 10 to the 23rd molecules in 1 mole. To find out the answer here, multiply across. Divide if you need to, which you don't really for this one because we only have a 1 on the bottom. Check your sig figs. How many sig figs are we keeping? 3. You should get 1.20 times 10 to the 24th molecules of water. P.S. Scientific notation is also about to become very important. Make sure you know how to do scientific notation on your calculator. If you don't, ask me or ask Mrs. Hooby. Next one. How many marbles are in 1 mole of marbles? I hope you could answer this question without seeing the answer or without seeing the math. Because how many is in 1 mole of anything? 6.02 times 10 to the 23rd. Let's do the math anyway so you can see it. 1 mole is what we're given, 1.00. We need to cancel the mole. So where does it go next? On the bottom. We know there's 6.02 times 10 to the 23rd of anything in a mole. How many sig figs should we keep? 3. And of course the answer is 6.02 times 10 to the 23rd marbles. If you had this many marbles, it would cover the entire Earth to a depth of 50 miles. That's a lot of marbles. Now we're going to add grams to the mix. Remember, the mole is the bridge from atoms to grams. How many grams are in 1.75 moles of neon? And it turns out we don't even need the atoms on this one because we're starting with moles. We're starting in the middle of the bridge.
Should we change this one up here? It says 1.
Oh yeah, let's change it on your page. Sorry, I forgot there's a typo. 1.75 moles of neon, please. Start with what you're given. We need to cancel the moles, so where did they go? On the bottom. How many grams are in 1 mole of neon? Where are you going to find that out? Find neon on the periodic table. 20.18 grams of neon in a mole. Check your sig figs. We should keep 3. After you round off, calculator will show you 35.3 grams of neon. How many atoms are in 1.50 grams of gold? Here's where we're going to treat the mole like a bridge. Start with what you're given. We need to cancel the grams so they go on the bottom. Remember, grams come from the periodic table. So you look up gold on the periodic table. 196.97 grams. That is per 1 mole. Oops, got my animations in the wrong order today. Oh, these are all messed up. Yeah, sorry about that, guys. Okay, so we need to cancel the grams. So from here to here, cancel the grams. That's the number of grams in 1 mole. Then we need to cancel the moles. So moles go down here next. We know that the mole is 6.02 times 10 to the 23rd atoms. Check your sig figs. Your sig figs come from the gram numbers and the atom number.